Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us deep into the secret architecture of reality itself, into the smallness that built everything, the air around you, the chair beneath you, the stars far above you, all of it, without exception, made from the same invisible ingredients. We'll drift through the story of how a universe that began with no atoms at all somehow learned how to weave them together, and how those tiny patterns became galaxies, life, and finally, you. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each of us in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the world of atoms together. And if your mind begins to wander, that's perfectly fine. Let it drift like starlight across the dark. We'll still be here, quietly unfolding the story, one calm thought at a time. If all the knowledge of science were to vanish, and only one sentence could be passed down to whoever came next, what should that sentence be? The physicist Richard Feynman once offered his answer. All things, he said, are made of atoms. It sounds simple, almost too simple, but inside those 6 words lies everything. The sky, the oceans, every heartbeat, every breath, every dream you've ever had. All things are made of atoms. Say it slowly and feel the weight of it. It's not just a fact, it's a kind of poem, written by the universe about itself. Imagine for a moment holding a smooth river stone in your palm. It feels solid, heavy, whole. But that solidness is an illusion. If you could shrink yourself down far beyond the reach of any microscope, you'd see that the stone isn't solid at all. It's almost entirely empty space, an intricate cathedral built of motion and distance. Each atom inside it is a tiny solar system of its own, a bright, dense heart called a nucleus, and around it, a faint, ghostly cloud where electrons drift, never still, never at rest. Those electrons move so quickly, almost 1% of the speed of light, that the stone feels firm to your touch, just as a hummingbird's wings blur into stillness when they beat too fast for your eyes to follow. Let's imagine for a moment that we could shrink down even further, becoming explorers in this invisible world. You might picture yourself as an atomonaut, drifting across the boundless space inside a single hydrogen atom. You start your voyage from its tiny heart, a lone proton glowing softly at the centre. Around you, nothingness stretches for what feels like eternity. You expect to find an orbiting companion, the atom's single electron, moving like a moon around its planet. But no matter how far you drift, you can't find it. Because the electron isn't in one place at all. It's a presence everywhere at once, a shimmering haze, a fog of possibility. The closer you look, the less certain everything becomes. You can only speak of where it might be, never where it is. That uncertainty isn't a flaw in our knowledge, it's a fundamental truth. The world beneath the visible doesn't behave like the one above it. At the smallest scales, nature whispers in riddles. The electron isn't a marble circling neatly, it's a cloud of maybes, a blur of probabilities that surrounds the proton like a soft breath. And that blur, that shimmering fog of maybe, is what allows chemistry, light, and life itself to exist. If we drift a little further into this story, we begin to see how miraculous this is. Every atom is almost entirely empty, yet together they build oceans, mountains, and mines. The nucleus at the centre is unimaginably small, but within it lies nearly all the atom's weight. Inside that nucleus, even smaller particles dance. Quarks and gluons, the restless keepers of the strong nuclear force, one of nature's deepest bonds. They hold the atom's heart together with a grip so powerful that gravity, compared to it, would feel like a faint sigh. And yet, this mighty clasp works only across the tiniest distances, smaller than imagination itself. It's the perfect balance, strong enough to bind the atom, gentle enough to let it exist. So here we are, creatures made of these invisible storms, built from patterns of motion and space. The air you breathe, the warmth of your skin, the stars that glow above, all born from this same quiet choreography. Every breath is a gathering of ancient atoms, some forged in long-dead stars, others unchanged since the beginning of time. The hydrogen in the water you drink might be 14 billion years old, a relic from the first seconds of creation. The carbon in your body was made in the heart of a star that burned its life away so you could exist. When you touch your chest and feel your heart beat, you're feeling a rhythm that began in that atomic truth. Atoms move, combine, fall apart, and combine again. They make blood and music, memory and dreams. They drift through generations, through stars and soil, through you and the air that will outlive you. In every atom that composes you, there's a quiet history, a record of the universe remembering itself. As we follow this thread a little further, we'll ask a deeper question. How did these atoms, these beautiful tiny architects of existence, come to be? Because once, long ago, there were none. The early universe was not made of matter at all. It was made of pure energy, blinding, dense, and without form. Somewhere in that endless brightness, light learned how to slow down and become matter. Energy curled into itself and began to take shape. Out of that first shimmering chaos, the recipe for atoms was written, a recipe that would lead, in time, to everything you know. But for now, you can rest in this thought. Every atom that makes you is part of a single ancient conversation, one that began at the dawn of time and continues quietly in every heartbeat, every breath, every grain of starlight that reaches your skin. The next part of our journey will carry us gently backward in time, toward that first light, to the moment before the first atom existed at all, when the universe was only a sea of fire waiting to cool into matter. If we follow the thread a little further, the story now carries us deeper, inside the very heart of an atom. You've probably seen those tidy textbook pictures. A round nucleus at the centre, tiny dots spinning neatly around it like planets circling a sun. It's a comforting image, but nature, as always, has her own sense of mystery. The truth is far stranger and far more beautiful than the little model on a classroom desk. Imagine again that you could shrink down, smaller and smaller, until the world around you begins to blur into pure motion. You slip past the level of cells and molecules, past dust motes and specks of light, until you find yourself drifting in the vastness of an atom. It isn't what you expect. There is no floor, no horizon, only a soft golden glow at the centre, the nucleus. If you could see it, it would be impossibly tiny, like a grain of sand floating inside a cathedral the size of the sky. And that grain holds almost all the atom's weight. Around it, the rest of the atom stretches out as emptiness. But not an empty emptiness. It hums. It feels alive, trembling with possibility. Somewhere in that vast invisible space lives the atom's single electron. Though lives might not be quite the right word. It doesn't orbit the nucleus like the moon around the Earth. It exists more like a mist, a gentle fog of presence. If you could reach out your hand, or whatever shape your hand might take at that size, you wouldn't touch a tiny marble. You would pass through a shimmer, a cloud of probability. The Danish physicist Niels Bohr once imagined the electron as a neat little traveller moving in circles. His model was simple, beautiful, and for its time, revolutionary. But as the science deepened, so did the mystery. We learned that an electron can't be pinned down. It doesn't occupy one place, but many possibilities at once, like a melody that can only exist while it's being played. We can describe where it's likely to be, but not exactly where it is. The universe, at this scale, speaks in maybes. Every location, every motion is a probability, a dance of chance that somehow becomes certainty when we look. If that sounds abstract, imagine standing in a room filled with fog. Somewhere in that fog is a firefly. You can't see it directly, but you can sense its glow. You take a step, and the glow shifts. Another step, and it vanishes. You can only talk about where it might be, not where it truly is. That is how electrons live, softly, uncertainly, everywhere at once. And yet from this strange uncertainty comes all the solidity in your world. The wood of a chair, the gleam of metal, the warmth of a human hand. Inside the nucleus, the mystery deepens. You might think of it as a tiny cluster of two kinds of beads. Protons, which carry a positive charge, and neutrons, which are neutral. The protons should repel one another, like trying to press two north poles of magnets together. By every common sense rule, the nucleus should fly apart. But it doesn't, because something unseen holds it fast. It's called the strong force, though that name doesn't quite capture its nature. It is the universe's most intimate embrace, a grip so powerful that even gravity, mighty enough to sculpt galaxies, is a faint whisper beside it. But this force works only across the smallest imaginable distances, a space so tiny that if you scaled the nucleus to the size of a mountain, the strong force would reach no farther than a grain of sand on its slopes. Within that tiny reach, though, it binds the heart of every atom in existence. Peering still closer, you'd find that even the proton and neutron are not simple things. They are little worlds of their own, made of 3 quarks each, a trio of unimaginably small points bound together by the strong force. But here's the twist. Those 3 quarks provide only a fraction of the proton's weight. Most of its mass, nearly all of it, comes from the restless energy of the bond that holds them together. It's as though the proton is made not of things, but of motion itself. A storm that never ends, a symphony of light and tension. The matter that makes up everything around you, even the matter that makes you, is mostly energy caught in a pattern, humming quietly in the dark. The quarks and the gluons that tie them together flicker in and out of existence faster than any eye or instrument could ever follow. Sometimes a gluon, which carries the strong force, transforms briefly into a pair of particles, a quark and its ghostly twin made of antimatter, before returning again to its original form. These short-lived pairs are called virtual particles, though that word virtual hardly does justice to their reality. They may exist for only the tiniest fraction of a moment, but their combined energy gives the proton its mass, and by extension, gives the universe its substance. You could say that everything you know is built from particles that are never fully there, an endless shimmer of becoming and vanishing. The whole cosmos, it seems, is a kind of dance between presence and possibility. And yet, out of that restless motion comes stability. Atoms, with all their uncertainty and emptiness, are astonishingly loyal. The ones in your body, those little whirlwinds of energy, will likely outlast the sun. The carbon in your bones was once part of a star that lived and died long before Earth even existed. The hydrogen in your blood is older still, a survivor from the first seconds after the universe began. Every breath you take pulls in ancient atoms, each one with a story longer than time itself. They have drifted through oceans and storms, through comets and clouds, through the veins of trees and the hearts of stars, and now, for a while, they gather in you, thinking, breathing, wondering what they are. If we drift further along this path, we begin to realize how fragile this arrangement truly is. The laws that let an atom exist depend on delicate balances. If the pull of electricity between the proton and electron were just a little stronger, the electron would spiral inward and the atom would collapse. If it were weaker, the electron would fly away and never be caught. If the strong force binding quarks were slightly different, the proton itself would fall apart. Everything we know hangs on these invisible symmetries, tuned so finely that even the smallest change would rewrite the entire story of existence. And yet, somehow, those dials were set perfectly, long before there was anyone around to notice. So as you lie there now, listening to this quiet unfolding, you are surrounded and filled by atoms. Each one is mostly empty space, but that space hums with energy and history. Inside every breath you take is the echo of the Big Bang. Within every heartbeat is the whisper of a star long gone. You are, in a very literal sense, made of starlight slowed into substance. And though you are small, your atoms carry within them the memory of the entire universe. The trail of clues leads us gently now toward the time before these atoms came to be, a time when there was no matter, no light that could travel freely, only a vast and radiant sea of energy waiting to cool and form the first building blocks of everything that would ever exist. As we drift further into the story, the quiet simplicity of the atom begins to peel away, revealing a hidden drama beneath its calm exterior. What seems steady and peaceful, the solid world beneath your fingertips, is, in truth, a constant storm. Every moment inside every atom is alive with motion. You can't hear it, but it's there. A low, endless hum, like the background note of creation itself. Think of something ordinary. Perhaps the wooden edge of a table or the silver band of a ring. To your eyes it is still, perhaps even ancient. But inside, at the scale too small for sight, trillions upon trillions of particles are dancing. The electrons are not sitting quietly in neat orbits. They are clouds of movement, a vibrating sea of probabilities. The protons and neutrons in the nucleus are also restless, quivering bundles of energy bound by invisible threads. Even when the object looks cold and unmoving, its atoms are alive, spinning, colliding, pushing and pulling in a ceaseless ballet. Let's float closer to that storm for a moment. Imagine diving inward again, past the fog of the electron cloud, down to the glowing heart of the nucleus. You would find the protons and neutrons packed together with incredible closeness, held tight by the strong nuclear force. If that force could be seen, it would look like a web of light, binding each particle to its neighbour with glowing filaments that shimmer and twist. Each filament hums with tension, like a string drawn taut across a violin. Without that tension, the nucleus would fly apart instantly, its particles repelling one another like magnets forced to touch. But the strong force doesn't shout its power, it whispers. Its grip is immense yet delicate. If you could turn a cosmic dial and make it only a little weaker, every atom in the universe would crumble. Make it slightly stronger, and no light would ever escape the stars. The very fabric of chemistry would vanish. It is balance, not brute strength, that keeps the universe whole. Nature's forces are tuned like a symphony, each note in harmony with the others. Inside the proton, things become stranger still. We once imagined protons and neutrons as simple, indivisible particles. But when physicists peered deeper, they found not solidity but chaos. Inside the proton are three tiny entities called quarks, two of one kind, one of another, held together by invisible carriers of the strong force called gluons. Yet those three quarks contribute almost none of the proton's weight. Nearly all of its mass, and therefore almost all of the mass in your body, comes from the energy trapped between them. The proton is not a thing so much as a process, a whirlpool of energy folding in on itself, forever renewing, forever in motion. The matter you touch, the air you breathe, even your own heartbeat. All of it is made from these restless loops of energy pretending to be still. Now imagine one of those gluons darting between quarks like a messenger made of light. For a brief, flickering instant, it can transform into a pair of particles, a quark, and its opposite twin made of antimatter, before vanishing again into the background storm. These pairs appear and dissolve so quickly that no instrument could ever catch them. But their momentary existence contributes to the proton's weight, like a whisper that adds to a choir. Physicists call them virtual particles, but in a poetic sense, they are like the universe breathing, inhaling existence, exhaling possibility, over and over again. What gives the world its mass is not a pile of stuff, but the vibration of relationships, the way energy bends and folds upon itself to create the illusion of form. It is a strange thought, but a comforting one. The solidity of your world comes not from stillness, but from motion, from invisible dances that happen too fast for you to see. Every stone, every cup, every heartbeat is a choreography of fields and forces, each one balancing perfectly against the other. When you press your hand against the surface of a table, you're not truly touching it. Your electrons are repelling the electrons of the table, creating an invisible cushion of electromagnetic force. That gentle pushback is what solid feels like. It's not contact, but resistance. A conversation between atoms saying quietly, "This is far enough." And yet, even within that conversation, there is emptiness. If the nucleus of an atom were the size of a small pebble, the nearest electron would be orbiting more than a kilometre away. The rest is space, empty, silent, waiting. You might think of the universe as mostly nothing, stitched together by patterns of energy so fine that they only seem like matter to our slow senses. What you see as structure, the shape of your hands, the surface of the moon, the curve of a leaf, is simply the architecture of that emptiness. Still, that emptiness is alive with potential. The energy stored in a single atom, if released, could light an entire city for a moment. You might recall the quiet equivalence, written by Einstein long ago, that energy and matter are two sides of the same truth. If you could weigh the world's calmness, its stillness, you'd find that it hums with energy waiting to be unwrapped. The atoms in your body are not static. They're quietly vibrating pieces of light, slowed and shaped into form. Every second they're exchanging tiny bursts of energy with the world, giving, taking, rebalancing. You're made of borrowed light, woven into a shape that can breathe. The more deeply we understand this, the more delicate the whole story seems. Everything, from the stability of a proton to the orbit of an electron, depends on tiny numerical coincidences, balances so precise that if they shifted even slightly, the world would not hold together. The charge of the electron, the strength of the strong force, the weight of the quarks, all perfectly matched, like notes tuned to a single chord. If any of them were off by even a breath, chemistry would collapse, stars would not shine, and life would never have learned to wonder. You might think of it as luck, or design, or the quiet logic of possibility itself. But whatever it is, it feels intentional. As though the universe knew it would one day look back at itself and smile. If you close your eyes and listen, you might even feel that faint hum, the echo of those atomic dances that built you, the warmth in your skin, the rhythm of your breath, the softness of your heartbeat. All of it is the music of atoms, singing the same song they've sung for billions of years. They have been part of stars, oceans, volcanoes, and clouds, and now they rest for a little while in the shape called you. Someday they'll drift away again to join another form, another story, another dream. From here, the story opens into the time before there was form at all, before atoms, before light could travel freely. The universe was still young then, a storm of brightness without boundaries, waiting for its first moment of calm, the moment when it learned how to build atoms that would one day gaze back in wonder. The path now carries us back to a time before the world had shape, before the first atom, before light could travel freely, before space itself had learned what it meant to be still. We're drifting toward the universe's childhood, not a gentle infancy, but a roaring, radiant beginning. If you could stand there, in those first moments after the beginning, you wouldn't see stars or galaxies or even darkness. You would see only light, endless, blinding light. Not the light from a flame or a sun, but light as pure energy, the kind that doesn't yet know how to slow down and become matter. The Big Bang was not an explosion in space. It was the birth of space itself. Everything, every future atom, every distant star, every quiet thought that would ever be, was compressed into a single glowing sea of energy. And then, in an instant that was both timeless and brief, it began to expand. Space stretched like warm dough rising in a cosmic oven, carrying with it the seeds of everything that would one day exist. At first, the universe was unimaginably hot, so dense that light and matter were one and the same. Energy constantly transformed into particles and then back again, a ceaseless conversion, like a flame that keeps eating itself. In that brightness, particles and their mirror opposites, matter and antimatter, appeared together, only to destroy each other a heartbeat later. It was a strange and violent symmetry. For every particle of matter, there was one of antimatter, and when they met, they vanished in a flash of energy. And yet, by the narrowest of chances, not everything was lost. For every billion pairs that destroyed one another, one lonely particle of matter survived. That tiny imbalance, that single surviving spark in a billion, would become the entire material universe. Every star, every planet, every person. You're here because the universe was imperfect, because it hesitated for just a fraction of a second in its perfect symmetry. That flaw was its gift to us. As the expansion continued, the cosmic fire began to cool. After just a few moments, still in its first breath of existence, the universe was no longer just light. It had cooled enough for quarks to settle into trios, forming the first protons and neutrons. It's strange to imagine. What we now call matter was, at that time, simply a new way for light to exist. Light that had curled in on itself, slowed down, and become tangible. You could say the universe learned how to hold its own brightness in its hands. These protons and neutrons swam through an ocean of radiation so intense that it glowed with every colour of light at once. If you could have heard it, it would have sounded like a deep, rolling thunder, a pressure that filled all of space. This was a universe that could ring like a bell. Sound itself travelled through the young cosmos, waves of compression moving through the hot plasma of particles and photons. These were the universe's first notes, low, slow, and resonant. They would later be called baryon acoustic oscillations, but perhaps it's gentler to think of them as the heartbeat of creation pulsing through that newborn light. Everything that would ever exist began as a wave in that glowing ocean. Some ripples were slightly denser, some a little thinner. Over time, those differences would become galaxies and voids, clusters of stars and the empty stretches between them. Every mountain, every ocean, every living thing carries the imprint of those early vibrations, the music the universe played before atoms even formed. For about 50,000 years after the beginning, light and matter were inseparable. The cosmos was a fog of energy where photons, the tiny messengers of light, could not travel far before colliding with electrons and protons. It was a universe that shone everywhere but could not see itself. Imagine being trapped in a maze of mirrors, where every direction looks the same and every step simply leads to another reflection. That was what light experienced then. Endless collisions, endless confusion. The temperature, though impossible to measure in human terms, can be imagined as the warmth of pure creation. so hot that nothing could yet take form. But the universe was expanding, and expansion is another word for cooling. As it grew, its energy stretched thinner, and the collisions became fewer. Gradually, the light began to lose its grip on matter. The fog began to clear. During this long cooling, something remarkable happened. Protons and neutrons began to find each other and hold fast. The strong nuclear force, the universe's great invisible glue, began to link them together in small clusters. These were the first atomic nuclei, the beginnings of hydrogen, helium, and a faint dusting of lithium. It happened quickly, within the first few minutes of cosmic time. A fleeting moment when the temperature was just right for creation. If it had cooled more quickly, the ingredients would never have found one another. If it had cooled more slowly, they would have collided too violently to stay bound. The universe, even then, was walking a tightrope between chaos and structure. In those few minutes, roughly 1/4 of all the matter became helium. The rest remained hydrogen. These two elements would become the universe's first alphabet, the letters from which every future atom, every molecule, every mountain and mind would be written. But the universe wasn't finished cooling yet. The electron still roamed free, colliding constantly with photons, trapping light in its endless maze. If you could have floated through that ancient light, you would have felt the pressure of radiation all around you, a luminous wind pressing gently on your being. The light then wasn't like the light of a lamp or the sun. It was thicker, heavier, almost tangible. It filled every space like water fills an ocean, luminous and alive. And so the universe waited. For hundreds of thousands of years it expanded, stretching its light thinner, softening its roar into a hum. Every pulse of expansion lowered its temperature a little more. Every passing millennium brought the cosmos closer to a calm where matter and light could finally part ways. One day, if days can even be counted at that scale, the balance tipped. The light loosened its hold on the matter that had once trapped it. Electrons slowed and settled into orbits around nuclei. For the first time, atoms were born. And as they formed, space itself became transparent. The first light that had ever been imprisoned now set itself free and began to travel outward, unimpeded through the vast silent dark. That light is still travelling. It has crossed almost 14 billion years of distance, stretched thinner and cooler as the universe continued to expand. Today, it fills the cosmos as a soft invisible glow, the cosmic microwave background, the whisper of that first dawn. When you lift your eyes to the night sky, the starlight you see is only the latest verse in a song that began with that first light. As we drift onward through the story, we'll follow that light, not the light of stars, but the afterglow of the universe's birth, to see how it became our greatest proof of where everything began and why atoms, against all odds, managed to survive. If we follow the thread a little further, we find the young universe still glowing, a sea of radiant fog filled with invisible music. There were no stars, no planets, no galaxies yet. Everything was still a smooth blend of light and matter, like a great cosmic soup gently simmering. But inside that brightness, something subtle began to stir. Tiny ripples moved through the plasma, compressing and expanding like the rise and fall of breath. The universe, for the first time, had learned to sing. It's hard to imagine sound in space, because today space is silent, too thin for vibrations to travel. But in that early time, space wasn't empty. It was thick, dense, and glowing, more like the inside of a star than the open sky we see now. Through that glowing matter, waves of pressure rippled outward, carrying patterns that would one day become the grand architecture of the cosmos. These were not ordinary sounds, not like wind or thunder, or the notes of an instrument. They were immensely deep, their wavelengths stretching for light years. Each wave took hundreds of thousands of years to complete a single crest and fall. To us, they would be inaudible, But if you could somehow compress billions of years of history into a single moment, you might hear them as a deep, resonant hum, the heartbeat of the universe itself. Scientists call these waves baryon acoustic oscillations, but you can think of them more simply as cosmic music, a memory of that first luminous ocean vibrating with energy. Every crest and trough in that ancient sound marked places where matter gathered slightly more densely. Those slight differences, no greater than the faintest whisper compared to the roar of light, became the seeds from which galaxies would grow. Where the rhythm of the waves pressed matter together, gravity began to take notice. Over billions of years, those subtle harmonies would shape the entire structure of the universe. Clusters of galaxies, filaments of stars, and the vast, silent spaces in between. You might imagine that early cosmos as an immense drum, stretched and resonant, struck only once at the moment of its birth. The reverberations of that single strike are still echoing through everything we see. When you look at a star or trace the spirals of a galaxy, you're seeing the frozen ripples of that first vibration. Even now, in the background radiation that fills the sky, those ancient frequencies remain, not as sound, but as temperature, as light, as memory. To understand how these cosmic waves came to be, we can picture the early universe as a conversation between light and gravity. Light wanted to move outward, spreading evenly, while gravity wanted to pull matter inward. Whenever matter began to clump together, light would push back, spreading it apart again. This back and forth, compression and release, push and pull, created the rhythm of the cosmos. It's the same principle that makes your voice carry through air, or a note ring through a string, only on a scale that dwarfs all imagination. The entire universe was vibrating with that rhythm, turning chaos into structure through the quiet logic of sound. But sound wasn't the only thing moving through that glowing fog. Within it, protons and electrons were still colliding constantly with photons, the particles of light. Each collision kept the universe opaque, like a thick cloud that refused to let light escape. For hundreds of thousands of years this continued, light trapped inside matter, matter stirred by light. It was a delicate dance of balance, every note shaped by the interplay between energy and gravity. If you could see it unfold, it would be breathtaking. Waves of brightness sweeping through an ocean of fire, expanding outward as space itself stretched. The wavelengths grew longer, the peak softer. The cosmic symphony was slowly lowering its pitch, turning from a sharp, fiery roar into a deep, patient hum. As the universe expanded and cooled, the notes became more drawn out, their energy slowly dissolving into calm. Eventually the song began to fade. The universe had cooled enough that protons could finally hold on to their electrons, forming the first neutral atoms. That changed everything. The fog that had trapped light began to clear. For the first time, the universe could see itself. The sound, once carried through a dense plasma, now had no medium left to travel through. The music stopped, but the imprint of its melody remained, written into the very pattern of space. Even now, when astronomers map the positions of galaxies across billions of light years, they can still trace the faint echoes of those waves. The galaxies not scattered randomly. They lie along great cosmic filaments, spaced in patterns that mirror the oscillations of that primordial sound. The rhythm that once rolled through the glowing fog is now frozen into the shape of the universe itself. Each cluster, each empty void, is a note in that ancient song stretched over eternity. In a way, you can think of yourself as part of that music. The atoms in your body were once vibrations in that early cosmic sea. The hydrogen in your blood began as a wave crest in that sound. When you breathe, the air you draw in is made from particles that once resonated to the same universal rhythm. Every part of you is a faint echo of that first harmony, the cosmos, humming quietly within your being. There's something strangely human in that idea. We've always been drawn to rhythm, to heartbeat, to breath, to melody. Perhaps we love music because we are made from it. The same physical laws that made the first atoms possible also make a drum reverberate or a voice sing. The universe itself in those early moments was singing its own creation into being. One day, long after we're gone, those cosmic notes will still be out there, stretched across expanding space, growing fainter but never truly gone. The song of creation will continue to hum softly beneath the silence, a soundless music that has no beginning and no end, carried by the memory of light. As our journey drifts onward, we'll watch as this sound gives way to form, as the universe cools further, allowing the first atoms to gather in peace. The moment when light finally escapes that glowing fog will mark the true dawn of structure, the first breath of clarity after the cosmic storm, and from that clarity a new story will begin, the story of how the universe took its first clear picture of itself. Our quiet exploration now turns to one of the most delicate intervals in all of cosmic history. A brief window so brief it could almost be missed, and yet within it, the entire recipe for matter was written. It lasted only about 20 minutes, a flicker of time compared to the age of the universe. But those 20 minutes determined everything that would ever come after. Every star, every world, every living thing made from atoms. We could call it the universe's first experiment in chemistry, a trial run at building something lasting from light. Imagine the young cosmos, still glowing with unbearable heat. It has been expanding for just a few heartbeats of cosmic time. The sea of particles we met before, protons and neutrons, light and radiation, now begins to cool just enough for new relationships to form. The strong nuclear force, that invisible clasp we met earlier, starts to link particles together, creating the first stable pairs. When one proton meets one neutron and holds fast, they form a deuteron, the simplest possible atomic nucleus beyond hydrogen. You might picture it like two tiny dancers finally finding rhythm in the storm, their arms locked together against the endless pressure of light. But this dance was only possible for a short while. The temperature had to be just right, hot enough that particles could collide and fuse, but cool enough that their bonds weren't instantly torn apart again. The universe walked this tightrope perfectly, as though guided by an unspoken harmony. If it had cooled faster, there wouldn't have been time for anything to join. If it had cooled slower, collisions would have broken every fragile bond before it could survive. The balance lasted only minutes, but it was enough. Within that golden window, deuterons began to join with other protons and neutrons, forming heavier nuclei. Two deuterons could combine to create a helium nucleus. Two protons and two neutrons bound together in perfect symmetry. These were the universe's first steps toward complexity. It was as though the cosmos, after being only light and chaos, suddenly discovered the joy of pattern. You can think of this period as the first quiet workshop in the universe, where simple particles learned how to build. In laboratories on Earth, scientists can recreate small pieces of this process, in fusion reactors, in the hearts of particle accelerators, and even more naturally in the cores of stars. But out there, in those first 20 minutes, it happened everywhere at once. The entire universe was the laboratory. Every point in space burned with the same temperature, glowed with the same light, and followed the same rules. Across all of existence, protons and neutrons were fusing, breaking, fusing again until the mixture settled into a stable blend. When the moment passed, the result was set. Roughly 3/4 hydrogen and 1/4 helium, with a dusting of lithium, the same ratio that still shapes the stars today. In human terms, this mixture might sound simple, but it was the difference between a barren universe and one capable of life. Hydrogen would one day become the fuel of stars, the building block of water, the spark of every flame. Helium, though quiet and noble, would help stabilize those stars and carry their heat outward. And lithium, though rare, would seed the chemistry of minerals and planets. In those 20 minutes, the universe wrote the alphabet of everything, just 3 letters to start, but enough to spell the future. Once that brief era ended, the furnace of creation began to cool too much for fusion to continue. Space expanded, the density thinned, and collisions became rare. From that moment onward, the universe would no longer create new atomic nuclei in any significant amount. The work would pass instead to the stars, which would take over billions of years later as the forges of heavier elements. But those first light elements, born in the opening minutes, were the foundation, the scaffolding upon which all future chemistry was built. As the heat faded, the universe entered a long, quiet adolescence. It was still bright, light and matter still bound together in a dense, glowing fog, but the furious activity had ended. The particles drifted freely now, carrying within them the memory of that first creation. The cosmos had taken its first breath, and now it exhaled slowly, letting its light expand into silence. If you could somehow float through that early light, you would feel it pressing gently against you, a warmth so pure that it had no colour, only brilliance. The photons, the tiny quanta of light, still filled every corner, colliding constantly with electrons and protons. Each collision blurred the universe's vision. No light could yet travel freely. The universe was radiant but blind, brilliant but unable to see. For hundreds of thousands of years it would remain this way, a glowing, restless fog awaiting the moment when clarity would finally dawn. It's humbling to realise how fragile this beginning was. If the strong force had been slightly weaker, the deuterons would never have formed. If slightly stronger, everything would have fused into helium immediately, leaving no hydrogen for stars or water. If the balance between light and matter had been different, expansion might have stopped or accelerated too quickly, and the whole story would have ended before it began. Everything we know, every galaxy, every song, every thought, is built on those exact conditions, held steady for just a few fleeting minutes. The universe had no second chances, yet somehow it got it right the first time. Today, the hydrogen formed in that brief cosmic moment still flows through the veins of stars. Every sunrise you've ever seen, every flicker of candlelight is powered by the same kind of fusion that once filled the entire universe. The light that warms your skin was born from the same process that, billions of years ago, turned raw energy into the first matter. When you look up at the stars, you're seeing the continuation of that 20-minute miracle, the universe still perfecting what it began in its first breath. As we drift gently onward, the scene before us begins to change. The glow dims, the temperature falls, and the first atoms begin to take shape. Electrons slow down enough to be caught by waiting nuclei, wrapping themselves around them like tiny moons. The fog of light begins to lift, revealing a cosmos ready, at last, to open its eyes. Soon the first light will break free, and with it, the universe will take its first true photograph of itself. The trail of the story now leads us into one of the most peaceful moments in cosmic history. The quiet dawn when light, after hundreds of thousands of years wandering through a glowing fog, finally found its freedom. The universe had been expanding and cooling all this time, patiently waiting for calm. And then, at last, that calm arrived. Imagine the universe then, roughly 380,000 years after the beginning, still unimaginably hot by human standards, yet far gentler than its fiery youth. The cosmic ocean of plasma, once blinding and turbulent, had cooled to about 4,000 degrees, warm enough to melt rock, but cool enough for the chaos to soften. The storm of collisions between light and matter began to fade. Protons and electrons, which had spent eons flying apart and slamming back together, were finally slow enough to meet and stay connected. In that stillness, the first true atoms were born. Each atom that formed was a small victory against confusion, a pocket of order in a sea of glowing energy. When a proton finally caught its partner electron, it became a hydrogen atom, the simplest and most abundant form of matter in the cosmos. A few helium atoms joined them, noble and light. Together, they filled space with the first true structures. Tiny, invisible, yet perfectly stable, the universe had learned the art of building things that could last. This era is known to scientists as recombination, though that word feels a bit too mechanical for something so graceful. Perhaps it's better to think of it as the first settling, the great cosmic exhale. The light that had been trapped for hundreds of thousands of years was suddenly set free. For the first time, photons could travel without being scattered or absorbed. The fog cleared. The cosmos became transparent. If there had been eyes to see, they would have witnessed the first sunrise in the history of everything. The light released in that moment still exists today. It has been stretching across space ever since, its wavelength growing longer and softer as the universe expanded. What began as brilliant fiery light has now cooled into a gentle background glow, a soft hum of microwaves that fills the entire sky. This is the cosmic microwave background, the oldest light we can see, and it carries with it the memory of that first moment of clarity. It is, in a sense, the universe's baby picture, an image of what everything looked like before stars and galaxies were born. Try to imagine it. Everywhere you look, in every direction, that light is still there, not visible to your eyes, but woven into the very air around you. It's faint, about 3 degrees above absolute zero, yet perfectly uniform. It wraps around us like an invisible cocoon, whispering the story of how the first atoms came to be. Every time you warm your hands near a fire, you're echoing that same act. Matter releasing its light. The only difference is scale. The universe was the fire, and space itself was the room it filled with glow. For a brief moment after recombination, the universe was a calm, uniform ocean of hydrogen and helium. There were no stars yet, no galaxies, no planets, only atoms drifting freely through space, bathed in the afterglow of their own creation. But even in that calm, there were tiny ripples, subtle variations in density, the fingerprints of those ancient sound waves that once moved through the cosmic plasma. In some places, matter was a little denser, in others, a little thinner. Those faint differences were enough. Gravity began its slow work, tugging gently on the denser spots, coaxing them to pull in more and more matter over time. The first structures of the universe were quietly beginning to form. The light that escaped during this time wasn't uniform either. It carried small variations in brightness and temperature, tiny clues about the way matter was arranged at that moment. Billions of years later, when scientists built sensitive instruments to study that ancient light, they found those faint patterns still imprinted on it. The slight differences, only a few thousandths of a degree, were the echoes of the earliest cosmic architecture frozen in light. The brighter spots marked where galaxies would one day form, where gravity would pull gas together to ignite stars. The darker spots mark the empty voids between them, the great spaces of nothing that would become the universe's quiet rest. It's humbling to think that everything we see today, from the Milky Way to the faintest twinkle of a distant star, began as tiny ripples in that primordial glow. Every atom in your body once drifted through that light. The hydrogen in your veins was there, floating in the calm after the storm, basking in the universe's first dawn. You're made not just of stardust, but of the same atoms that once welcomed the first light. If you were somehow able to travel back to that moment, you wouldn't need a telescope to see beauty. The universe itself would be radiant. The entire sky would glow a soft orange-white, fading slowly as it expanded. It would have been utterly silent, yet filled with a sense of beginning, as though The cosmos were taking its first slow breath after a long cry. The light wouldn't come from stars but from space itself, a perfect, even brightness stretching everywhere. Then, gradually, as the expansion continued, that colour would shift and cool, moving through shades of gold, then red, then infrared, and eventually into invisible microwaves. That's where it still rests today. The oldest light, forever travelling, forever whispering. And we can still see it. If you tune an old-fashioned television between channels, a small fraction of the static on the screen comes from that ancient light, the faint glow of creation itself. It's astonishing to think that the same photons that once brushed against the first atoms now flicker softly on human machines. Every spark of that static is a direct message from the dawn of time, still crossing the sky after more than 13 billion years. The light never stopped, it only stretched. In that sense, the universe has never truly gone dark. Every moment since then, that first light has continued to travel, to cool, to remember. The stars we see at night are only the most recent flickers in an unbroken chain of illumination that began back then, when the cosmos took its first clear breath. You and I, every planet, every cloud, every tree, are built upon the stability that this moment created, the calm that allowed atoms to survive, to gather, to dream. As our journey continues, we'll follow that ancient light more closely, to the moment when it was discovered again, long after it had faded from sight, by people looking up at the sky with nothing more than a radio antenna and a bit of curiosity. The story of how we found that forgotten glow is a story not just of science, but of serendipity, humour, and the timeless human urge to listen for whispers in the dark. From here, the story opens into one of the most charming chapters in all of science, a tale of light, curiosity, and a bit of bird droppings. Until now, we've been following the universe as it built its first atoms and released its first light. But for billions of years, that ancient light went unnoticed, quietly crossing the dark, wrapping the cosmos in a gentle glow invisible to human eyes. When at last we learned how to listen, it came to us not as brightness, but as a whisper, a faint hiss from the sky, carrying the memory of the universe's first breath. The story begins in the middle of the 20th century, long after the first stars had formed, long after the Earth had cooled and humans had learned to look upward with telescopes. By then, we had discovered galaxies, mapped the planets, and even sent our first signals beyond the atmosphere. But the idea that the universe might still be filled with the glow of its own creation was almost forgotten, a prediction lost in papers and footnotes, waiting for a pair of unsuspecting listeners to stumble upon it. One of them was a young physicist named Robert Dicker, a quiet, inventive man with a mind like a tuning fork, always listening for hidden harmonies. Dicker had a fascination with radiation, the kind of energy that lingers invisibly in space. He had spent years during the war working on radar, using microwaves to find airplanes in the sky. But afterward, his curiosity drifted further upward. He wondered if the universe itself might give off a kind of echo, a soft radiation left over from the beginning. He imagined that if the universe began in fire, that fire must have left behind a glow, stretched and cooled by the expansion of space. Over billions of years, that glow would no longer shine as visible light, but as microwaves, gentle, invisible ripples still moving through the cosmos. Dickey built sensitive instruments to search for this faint afterglow, but he wasn't in a rush. The idea was bold and the equipment delicate. He worked patiently, fine-tuning his designs at Princeton University, unaware that just a short drive away, two other men were about to find exactly what he was looking for. Arno Penzias and Robert Wilson were radio astronomers working at Bell Laboratories in New Jersey. Their goal was simple, at least on paper. They were testing a huge antenna, built to catch radio signals bouncing off satellites. The antenna itself looked like a metal horn, smooth, curved, and pointing toward the sky. But something was wrong. No matter which direction they pointed it, they kept hearing a faint, persistent hiss, a background noise that refused to go away. At first, they thought it must be interference, perhaps distant radar or the hum of the city. They checked every cable, replaced every component, even cooled their receiver with liquid helium until it was nearly as cold as outer space. The hiss remained. Then they noticed something else. Pigeons. A pair of them had built a nest inside the great metal horn, leaving behind what Penzias later described, with delicate scientific politeness, as a white dielectric material. In simpler terms, bird droppings. The astronomers gently captured the pigeons, cleaned the antenna, and even released the birds far from the site, only for them to fly straight back. In the end, they had to take stronger measures, though Penzias always spoke of it with a sigh of regret. Still, when the horn was spotless and silent, the hiss continued. It came from everywhere, from every direction, constant and stubborn, as if the universe itself were whispering. Frustrated, Penzias began calling other scientists for advice. One day, he reached out to Robert Dick's group at Princeton. On the other end of the line, Dick listened quietly, then turned to his team and said, half laughing, half sighing, "Well, boys, we've been scooped." The glow he had been searching for was real, and someone else had already found it by accident. That persistent hiss was not noise. It was the oldest light in the universe, the same light that had set itself free when the first atoms formed, now cooled and stretched by time into microwaves. Penzias and Wilson had discovered the cosmic microwave background, the echo of creation itself. When the discovery was announced, the scientific world was stunned. Here was proof, as gentle as a whisper, yet as undeniable as sunrise, that the universe had once been a hot, dense sea of light and matter. This light was a snapshot of that time, preserved perfectly. Every tiny fluctuation in its brightness told a story. The density of the early universe, the seeds of galaxies, the fingerprints of the first atoms. It was quite literally the baby picture of the cosmos. Imagine holding a photograph of yourself as a newborn. The features are soft, unfinished, yet unmistakably you. The same is true for the universe. The patterns of temperature and light in that cosmic glow are the earliest traces of everything we see today. The same structures that would later grow into clusters of galaxies in the vast cosmic web. The entire future was written there, hidden in faint ripples of microwave light. Even more wondrous is how ordinary this relic has become. It is everywhere. If you could build a perfect radio tuned just right, you could hear the universe's childhood in your living room, not as a melody, but as a soft static that fills all of space. Astronomers have since mapped that light in exquisite detail, colouring its invisible variations into images that look like painted skies, golden and blue, mottled with warmth and coolness. Those maps are not just data, they are portraits of the universe as an infant, drawn in the light of its own making. When you step outside at night and look up, the darkness above you is not truly dark. Behind the stars and the velvet black of space lies that same ancient glow, spread thin by time. It is too soft for your eyes to see, but it bathes everything. The air, the oceans, your skin. Every night sky is painted over that invisible memory, the universe remembering its childhood. And perhaps, in a quiet way, we are remembering too. Every atom in your body was once part of that glow, warmed by the same light that still drifts through space. When you close your eyes and feel the faint warmth of a sunbeam, you're touching a continuation of that first light, a light that has never gone out. As we follow the story a little further, that whisper of ancient radiation will guide us to a familiar place, a living room, a small screen, and the gentle crackle of static. Because even in our modern world, that ancient memory still finds ways to reach us, flickering quietly between the channels of a forgotten television set. If we drift a little further along this thread, the story of that ancient light becomes more intimate, because it isn't confined to the vastness of space. It has found its way quietly into our homes, our machines, even the screens we stare at. You may not have realised it, but if you ever watched an old television set, the kind with a rounded glass face and a dial instead of buttons, you've already seen the afterglow of creation. Every time the screen filled with a snowy blur of static between channels, about 1 tiny % of that flicker came from the birth of the universe itself. It's a strange and beautiful thought, the oldest light in existence hidden inside the hum of human technology. Long before we built satellites or digital telescopes, that cosmic memory was already whispering in our living rooms, announcing itself in the soft crackle of a television left between stations. The static that once annoyed viewers was, in truth, the quiet voice of the cosmos saying, "I am still here." Let's picture it. The room is dim, perhaps evening. The TV hums faintly, its curved glass glowing with dancing specks of black and white. If you could slow down the static, freeze it, you'd see a sea of tiny random flashes, each one a messenger. Some come from radio signals bouncing around the planet, some from local electronics. But buried among them are photons that have travelled since the dawn of time. They left the early universe almost 14 billion years ago, wandered through all of cosmic history, and then, by a chain of coincidences, landed softly on a human-made screen. That glow, that faint shimmer, is the oldest picture in existence still in motion. Scientists later captured this light in far greater detail than any television could, using satellites designed to measure the faint variations across the entire sky. The first maps looked like mottled clouds, patches of slightly warmer and cooler regions, though the difference between them was minuscule, barely a few thousandths of a degree. Yet those subtle freckles in the light told an extraordinary story. They showed where the universe was slightly thicker, where gravity would later gather matter into galaxies, where the first seeds of structure were sown. Those delicate variations, tiny ripples frozen in time, are the reason anything exists at all. If you could see that map stretched across the sky, it would look like a gentle watercolour painting, gold and sapphire streaked with faint lines and swirls. Each pattern represents the energy of the early universe, translated into colour. The brighter areas mark where the young cosmos was just a little warmer, a little denser. Those were the spots that gravity would later amplify, pulling hydrogen together, kindling the first stars. The cooler areas would become the great voids, the stretches of almost nothing that give galaxies room to breathe. In a poetic sense, this light is like a portrait of the universe's face as a child. Innocent, blurred, but full of promise. It's easy to forget that this glow isn't coming from a star or a planet, but from space itself. The entire universe was once luminous, and what remains of that radiance still hums softly around us, like a lullaby that never stopped playing. There's something humbling in realizing that our world, with its cities, its voices, its brief human dramas, is built atop this slow, enduring light. The same photons that now bounce from the pages of your book or the screen in front of you are the descendants of that first freedom. Light has been travelling ever since, spreading across the expanding fabric of space, never aging, never tiring. It touches everything: the quiet of the ocean floor, the dust on a windowsill, the skin of your hands. It connects every atom to that same ancient moment when the universe became transparent and self-aware. When you see the Milky Way stretch across the sky, you're looking through layers of time, starlight only a few thousand years old resting upon a backdrop of light billions of years older. The stars are new, but the background is ancient, a soft reminder that the universe still carries its own memory. Every night sky is a palimpsest, an old page written over many times but never erased. That light, the cosmic microwave background, is more than just evidence of the Big Bang. It is the most perfect record of balance the universe has ever kept. It shows us that, even in its first moments, the cosmos was astonishingly uniform. Only the tiniest imperfections, 1 part in 100,000, gave rise to everything: galaxies, stars, planets, and life. Without those tiny irregularities, there would have been no gravity wells to collect gas, no stars to forge heavier elements, no Earth, no us. The freckles on that cosmic photograph are the fingerprints of creation itself. And somehow, through sheer coincidence or cosmic poetry, we turn that ancient whisper into a form we could see and hear again, on screens, in speakers, in instruments built by curious hands. When Penzias and Wilson first measured the cosmic hiss, they didn't just hear noise, they heard the background music of existence, and every time we map the CMB, every new image, every refined detail, it's like unwrapping an old family album and finding another picture of our beginnings. It's strange how far the universe's voice has travelled to reach us, and how quietly it speaks when it arrives. The photons that make up that light have passed through countless transformations, stretched by space, cooled by time, brushed aside by gravity. Yet they still carry the same message. I was there when it began, and now we carry that message forward. Every telescope pointed at the heavens, every satellite scanning the faint glow, every child gazing up at the stars, all are acts of remembrance. Through us, the universe continues to look back at its own reflection, trying to understand how it became what it is. From these faint ripples and freckles, gravity would begin its patient sculpting. It would gather the hydrogen and helium into clouds, draw those clouds into stars, and those stars into galaxies. The story that began as light will now turn toward motion, toward the invisible forces that hold the entire cosmic tapestry together. So, as we leave behind the hum of ancient light and drift toward the next chapter, take one last moment to imagine the glow beneath the darkness of the sky. It's there, all around you. The first light, still alive, still whispering through every particle of your being. And soon we'll explore what kept it all together, the 4 invisible threads that bind the universe into form. The path now carries us from light to the hands that hold it, the 4 quiet forces that shape everything that exists. They are not forces in the way we feel a push or a pull when lifting something heavy. They are deeper than touch, woven into the very fabric of being. Each one plays a part in the story of atoms, stars, and life itself. Together they form a kind of cosmic choreography, 4 invisible threads stitching the universe into what we know. The first of these is gravity. You felt it every day of your life. The soft weight that anchors your feet to the ground, the pull that brings a raindrop home, the curve that keeps the moon circling the earth. Gravity is the universe's oldest gesture, the hand that holds everything close. It doesn't shout, it whispers. It is incredibly weak when compared to the other forces, yet its reach never ends. A single grain of sand exerts gravity, though so faint you'd never notice. But gather enough grains, and that whisper becomes a song strong enough to pull whole stars together. You might imagine gravity as patience itself. It doesn't rush. It works across billions of years. Every mountain, every planet, every orbit is its slow sculpture. It was gravity that gathered the hydrogen and helium left from the Big Bang into clouds, then into stars, and finally, into galaxies. It's the reason the universe has shape and rhythm instead of being a lonely mist. Gravity doesn't ask for attention, it simply waits, and in that waiting, everything falls into place. The second force is electromagnetism, the spark of connection. If gravity is the hand that holds, Electromagnetism is the light that dances between those hands. It's what keeps electrons bound to protons, what lets atoms form bonds, what makes light possible at all. Every colour you see, every warmth you feel, every signal carried through the air, all of it is electromagnetism in motion. Picture a candle flame, the glow, the heat, the way it warms your skin even from a short distance. That is electromagnetism speaking softly to your senses. On the smallest scale, it is the thread that lets one atom recognise another, that draws molecules into the shapes that will someday breathe and dream. Without it, the universe would be dark and silent, a stage without light, a dance without partners. The third force reaches deeper still, the strong nuclear force, the clasp that binds the heart of every atom. You met it once before, in the glowing core of the proton, where quarks are held in a ceaseless embrace. This force is fierce and faithful, the mightiest bond in existence, yet one that works only across distances smaller than imagination. It is what keeps the nucleus of an atom from flying apart, even though the protons inside are all positively charged and should repel one another. You might think of it as the gravity of the very small, a kind of devotion that never lets go. If gravity shapes the stars, the strong force builds the matter within them. Without it, no atoms could exist, no worlds could take form. It is the universe's firmest promise that things can hold together even when every other rule says they should not. And finally, there is the weak nuclear force, the quietest of all, and perhaps the most mysterious. Its name might suggest fragility, but it carries the power of transformation. It allows particles to change identity, to turn into something new. It governs the process we call radioactive decay, the slow rearranging of matter into energy and energy back into matter. Without this subtle force, the stars would never burn. They would sit cold and eternal, and the universe would remain static and silent. The weak force is the whisper of change, the spark of impermanence that makes time meaningful. It teaches the cosmos how to evolve. Every ray of sunlight that touches the earth, every warm afternoon, every glimmer reflected on a wave, all of it exists because the weak force allows hydrogen inside the sun to fuse into helium, releasing light in the process. Without weakness, there would be no light, no warmth, no life. 4 forces, 4 gestures, the hand that holds, gravity, the spark that connects, electromagnetism, the clasp that binds, the strong force, and the whisper that transforms, the weak force. Each one alone is incomplete. Together they are the framework of reality, the chords of the cosmic song. If you could see them at work, you'd witness an orchestra without instruments. Gravity keeps the stage steady. Electromagnetism conducts the melody. The strong force beats the rhythm deep in the atomic core, and the weak force adds the soft, slow changes that let the music move forward. Without any one of them, the song would stop. Their balance is astonishing. If gravity was slightly stronger, stars would collapse too quickly, burning through their fuel in a flash and leaving no time for life. If weaker, matter would drift apart and never form stars at all. If electromagnetism were altered, atoms might not hold together or could hold too tightly, making chemistry impossible. If the strong force changed even slightly, the protons and neutrons in every nucleus would either cling too hard or refuse to join. And if the weak force didn't exist, the universe would be frozen, eternal but lifeless. The fact that all 4 work together so seamlessly feels almost improbable. It's like finding an ancient instrument that plays itself, every string perfectly tuned despite the chaos around it. Each force pulls in a different direction, yet somehow they balance, each yielding space to the others, forming a unity that allows existence to persist. We don't feel these forces directly, at least not consciously, but they are always there, beneath every breath, every heartbeat, every flicker of light. When you drop a pebble into a pond and watch the ripples expand, you're seeing their conversation. When you switch on a lamp, you're watching electrons respond to electromagnetism. When you hold your hand to your chest and feel the warmth beneath your skin, you're feeling the work of the weak force in the sun, 93 million miles away, keeping you alive. These four invisible threads tie everything together, from the smallest proton to the largest galaxy cluster. They are both intimate and infinite, reaching across scales beyond comprehension. You could say that they are the language the universe uses to speak to itself and to us. As we drift onward, we'll follow one of these threads more closely: the strong force, the clasp that holds the smallest parts of the atom together. It is fierce, brief, and essential. The strength that hides inside stillness, the silence that keeps the universe from unraveling. As we follow the thread a little further, we arrive at one of the universe's most mysterious and loyal companions, the strong nuclear force, the clasp that keeps the heart of every atom whole. It's a strange paradox of nature. The smallest distances are held together by the greatest strength. In that invisible realm, power and intimacy are one and the same. You might imagine this force as the guardian at the center of all things. It binds protons and neutrons so tightly that nothing else can pull them apart. And yet, it works only within a space so small that even a single atom is a vast wilderness by comparison. The strong force is like a bond between friends who must stand shoulder to shoulder to feel its warmth, step even a hair's width apart, and it fades completely. Inside every proton, the strong force is endlessly busy, though we never see its work. If you could somehow shrink yourself down to that scale, you would witness a storm that never rests. Flashes of energy, ripples of light, particles flickering in and out like waves on a restless sea. This is where quarks live, the smallest building blocks we know, bound together by invisible threads called gluons. But those threads are not quiet. They shimmer with energy, constantly tugging, weaving, vibrating. The gluons are the messengers of the strong force. You might picture them as tiny sparks darting between quarks, holding them together through pure tension. It's hard to grasp just how powerful this clasp is. If you could take two protons and try to separate them, you would need a force greater than anything a human mind could conceive. Even the gravity of an entire planet would be feeble beside it. And yet, for all its strength, the strong force is gentle in its purpose. It doesn't destroy, it unites. It doesn't command, it holds. Without it, every atom would fall apart instantly, and the universe would dissolve back into scattered light. The way it behaves is unlike anything else in nature. Most forces weaken as objects move farther apart, but the strong force plays by different rules. The more you try to pull quarks away from one another, the harder it pulls them back, as if space itself resists the separation. It's as though the universe refuses to let its smallest pieces be lonely. And when the pull becomes too great, something remarkable happens. Instead of letting the bond break, the energy of the attempt transforms into new matter. The force creates more particles rather than allow emptiness. Even in its most violent form, the strong force chooses creation over destruction. Inside a proton or neutron, this process never stops. The quarks dance endlessly, exchanging gluons in a blur of movement so fast it defies all imagination. Sometimes the energy between them flares high enough that new pairs of quarks and their mirror opposites, little bursts of matter and antimatter, appear for a heartbeat before vanishing again. Physicists call them virtual particles, but that word feels too pale. They are like ripples on the surface of being, waves of existence that come and go faster than time can count. When all this is taken together, the quarks, the gluons, the flickering of new particles, we realize something astonishing. Almost all the mass of everything around you doesn't come from solid matter at all. It comes from the restless energy of this tiny storm inside protons and neutrons. the weight of a mountain, the density of your own bones, the solidity of the world, all of it arises from motion, not substance. Matter, it seems, is simply energy caught in a dance too intricate to dissolve. In that sense, the strong force is the quiet architect of everything tangible. It built the nuclei of atoms during the universe's first few minutes, stitched them together in stars, and continues to hold them steady even now. Every heartbeat, every grain of dust, every drop of water exists because of this invisible bond. You might think of it as the world's most steadfast promise, one that has never been broken since the dawn of time. To understand how it fits into the grand picture, imagine the four forces we spoke of as companions standing around a campfire. Gravity sits far away, its reach endless but faint, shaping the night sky with slow gestures. Electromagnetism tends the flame, vibrant and lively, painting light across the dark. The weak force hovers near the embers, whispering quiet changes that let the fire breathe. And the strong force sits right at the centre, hands clasped tight around the sparks, keeping them from flying apart. It doesn't speak much, but without its steadfast silence, the whole gathering would scatter into the wind. The strong force also writes one of the universe's most beautiful paradoxes, the idea that true strength often hides in the smallest of places. We tend to associate power with size, with grandeur, with loudness. But in the realm of atoms, the opposite is true. The smaller you go, the greater the force becomes, until power itself becomes invisible. A strength so immense that it must hide to exist. It's a reminder that the universe treasures balance, that stillness and strength can live side by side. When you touch your hand to your heart, when you hold a cup or lean against a wall, what you feel as firmness is, at its deepest level, the work of the strong force. Inside that solidity, the quarks and gluons are still dancing, binding the nucleus together moment by moment. Stillness, as it turns out, is an illusion. Even the most solid stone is a storm of energy pretending to be calm. And perhaps that is one of the quiet lessons hidden within the atom. Strength doesn't always announce itself. Sometimes it is the stillness that keeps everything from falling apart. The strong nuclear force, that unseen clasp, embodies this truth. It is the foundation of stability, the heartbeat inside matter, the still hand beneath creation's trembling surface. As we move gently onward, we'll meet its quieter companion, the weak force. It has none of the strength of this mighty bond, yet without it the universe would never change, and light would never shine. If the strong force is the guardian of what is, the weak force is the permission to become, and through its delicate transformations, the stars learn to burn, and the cosmos learns how to age gracefully. If we follow the thread a little further, the universe begins to whisper again, this time with its gentlest voice, the one that changes everything without ever raising its tone. We've seen the strong force, fierce and loyal, holding the heart of the atom together. Now we meet its opposite, the weak nuclear force, subtle and shy, yet quietly responsible for some of the most important transformations in the cosmos. It is, in a way, the artist of impermanence, the power that allows matter to change, to evolve, to shine. The weak force works in secret. You'll never feel it and you'll never see it at play. Yet every beam of sunlight that warms your skin, every flame that flickers, every breath of warmth rising from a living thing is born from its handiwork. If the strong force builds, the weak force transforms. It teaches matter how to become something new, how to trade mass for light and silence for song. At first, the name weak seems unfair. It sounds fragile, hesitant, like something the universe could do without. But the truth is the opposite. Without this soft power, stars would never burn. Hydrogen would never fuse into helium. The heavens would be cold, unchanging, and utterly still. The weak force is the quiet permission slip for transformation. the one that lets atoms rearrange their parts and release light in the process. Let's imagine, for a moment, what happens inside the sun. Deep within its golden heart, under pressure so immense that even light takes thousands of years to climb its way out, hydrogen atoms are pressed together until they merge. This act, the birth of a new element, is possible only because of the weak force. It allows one of the protons to change its identity, turning into a neutron. It's a tiny change, invisible and instantaneous, yet it alters everything. With that single shift, the sun becomes a factory of light. Every sunrise, every spark of warmth, every glimmer reflected on the sea begins with that quiet transformation. It's astonishing to realize that the heat of a summer day, the brightness of a candle, the energy that powers your heartbeat, all come from the same gentle mechanism. A proton turning into a neutron inside some star long ago. The weak force is the engine of all starlight, and through starlight, the engine of life. In physics, these transformations are called decays, but that word feels too bleak for something so beautiful. In truth, it's more like renewal, a passing of energy from one form to another, an exchange that keeps the cosmos in motion. You could say the universe breathes through the weak force. Matter exhales light, and light in turn gives life back to matter. What makes this force weak is not its importance, but its range. It acts only over distances far smaller than an atom, even smaller than the nucleus itself. Yet within that tiny reach, it shapes the destiny of stars. It decides when elements form and when they fall apart. It is responsible for radioactive decay, that slow ticking clock of atomic change. On Earth, we see it in the decay of uranium and carbon, processes that heat the planet's interior and power the chemistry of life. The weak force keeps the world's fires burning quietly from the inside out. It's remarkable how such a short-ranged, delicate interaction can sculpt the entire history of the universe. Without it, the stars would never forge the heavier elements we depend on. Carbon for our bodies, oxygen for our breath, iron for our blood. The strong force holds matter together, yes, but the weak force makes matter generous. It allows atoms to give up part of themselves, to transform and create something new. The universe, it seems, needed both strength and softness to come alive. Even now, particles born in the heart of stars stream through you every second, ghostly travellers called neutrinos. They are the messengers of the weak force, tiny flecks of information carrying whispers from the nuclear fires that made them. Trillions pass through your body every moment, unnoticed, unimpeded, connecting you directly to the core of the sun and to distant supernovas across the galaxy. You are, in a literal sense, bathed in the breath of stars. There's something deeply poetic about that. The weakest force in the universe connects everything that shines. It turns loss into light, change into warmth. It is the reason decay does not mean death, but renewal. It shows that even in the smallest corners of creation, the universe never stops reinventing itself. You might think of the weak force as the counterpoint to time's arrow. It gives direction to the unfolding of events. Without it, there would be no asymmetry, no preference for one state over another, no flow from past to future. The cosmos would be perfectly balanced but frozen, unable to move forward. The weak force tilts the scale, allowing history to happen. It's the quiet decision that lets the universe evolve. In this way, the weak force teaches a gentle truth. Even weakness can be power when it allows growth. It is the universe's reminder that change, though sometimes subtle, sometimes painful, is what makes life luminous. Every transformation, from the birth of a star to the beating of a heart, follows this same principle. Nothing stays the same forever, and that is how the cosmos keeps singing. When you watch the sunset and see the light fade into the horizon, remember that what you're witnessing is the song of weakness, hydrogen changing form, energy flowing outward, light travelling across space to kiss your eyes. That faint warmth on your skin carries the memory of nuclear change deep inside the sun, and the pattern of that change has been the same since the first stars lit the sky. Together, the strong and weak forces form a kind of partnership, one that holds and one that releases. The strong force keeps the heart of matter steady, while the weak force lets it breathe. Between them lies balance, the power to endure, and the grace to transform. You might even say they are the universe's yin and yang, not opposites, but complements, each making the other possible. And as their work continues quietly and endlessly, a question begins to emerge in our story, one that has haunted every thinker who has ever looked at the stars. How can all these forces, so different in nature and scale, be tuned so perfectly that atoms can form, stars can shine, and life can wander about them? Were the settings of this cosmic orchestra chosen, or did they simply fall into place by chance? The answer, or perhaps the mystery, lies ahead. Our quiet path now turns toward the balance of the universe itself, to the delicate dials and cosmic coincidences that make reality possible. We're about to step into the control room of creation, where even the slightest adjustment could erase everything we know. Our quiet exploration now steps into a strange thought experiment, part philosophy, part science, and entirely a meditation on luck. Imagine you stand in a quiet courtyard, blindfolded, with the sound of footsteps all around. You hear rifles being raised. 20 soldiers stand in a circle, their weapons aimed at your chest. The air holds its breath. There is a single command, and then 20 cracks of gunfire. When the smoke clears, you are still standing, every single bullet missed. At first, the mind tries to explain it. Perhaps they were kind, perhaps they aimed poorly, perhaps against every expectation they all missed by chance. But however you reason it, the fact remains. If you're standing there to think about it, something deeply improbable must have happened. This thought experiment, offered by philosopher John Leslie, is a way of understanding how astonishing it is that atoms, and by extension you, exist at all. The odds against our universe producing stable matter are beyond comprehension. It's not that we were lucky once, it's that every law of physics had to line up perfectly, every constant finely balanced, every force tuned within impossibly tight boundaries. One stray shot, one tiny change in the rules, and the whole cosmic story would have ended before it began. And yet, here we are, still standing, still breathing, still thinking about it. Let's imagine what those bullets represent. Each one could be a fundamental constant of nature. The strength of gravity, the pull of electromagnetism, the mass of a proton, the charge of an electron. Each value sits within a narrow range that allows atoms to exist. Change any of them ever so slightly, and the universe would be unrecognizable. If gravity had been a touch stronger, stars would collapse quickly into black holes before life could ever form. A touch weaker, and the gases of the early universe would have drifted apart, never igniting into stars at all. If electromagnetism were altered even by a fraction, electrons might never settle into orbits around nuclei. Atoms would crumble, chemistry would vanish, and the world would dissolve into a thin mist of light. Even deeper, inside the atomic heart, the balance of the strong nuclear force had to be perfect. Make it a little weaker, and protons and neutrons would fail to bind together. No helium, no carbon, no stars burning in their steady rhythm. Make it a little stronger, and they would cling too tightly, collapsing into heavier elements before the story of a light could even begin. In both cases, there would be no diversity, no chemistry, no life. And then there's the weak force, the quiet whisper that lets atoms transform and stars shine. If it were weaker, the fusion inside stars would barely flicker, leaving the cosmos dim and cold. If stronger, stars would burn too fast, consuming themselves in seconds instead of billions of years. Every constant, every ratio, every relationship seems balanced at the edge of disaster, yet somehow it all fits, like the tumblers of a lock turning perfectly into place. Physicists call this fine-tuning, but that phrase barely captures its wonder. It's more like a cosmic coincidence so vast that we can only bow to it in awe. Imagine standing before a vast control panel, an impossible machine with thousands of glowing dials, each one controlling a property of the universe. On one dial, the strength of gravity. On another, the charge of the electron. Others for the mass of quarks, the speed of light, the ratio of matter to antimatter. The dials must be set precisely, each within a whisper of perfection. You look at the panel and realise that if even one knob were turned the slightest bit, atoms would never form, the stars would never shine, the universe would have been stillborn. And yet somehow, all the settings are exactly right. It's easy to imagine some unseen hand arranging those dials. But perhaps what makes the picture even more mysterious is the possibility that no one adjusted them at all. That the universe simply is this way, not because it must be, but because this is one of the rare combinations where existence can unfold. Like the survivor of the firing squad, we stand here not because the odds favoured us, but because in all the places where the bullets didn't miss, there would be no one left to wonder why. Still, even knowing that doesn't quiet the feeling of astonishment. Why should the constants align so precisely that atoms can form stable bonds? That stars can live long enough to forge elements? That planets can cradle oceans? And that life can look up and ask these questions? It's almost as if the universe, from the very beginning, carried within it the potential to know itself, a seed of consciousness hidden in the laws of physics. Some scientists see this fine-tuning as a coincidence too grand to ignore. Others see it as a hint that perhaps we misunderstand what chance really means. Maybe the universe wasn't adjusted to create us. Maybe we arose, naturally, in the only kind of universe that could create anyone at all. In that sense, our existence isn't an accident, but a necessity. We are the witnesses that reality produces when the laws permit matter to remember its own beginnings. And yet, even if that is true, it doesn't make it feel any less miraculous. The difference between a universe filled with light and a universe filled with nothing may hinge on differences smaller than any measure we can imagine. In the grand story of time, that's as thin as a sigh. So we return to the courtyard, blindfolded, the rifles raised. We listen to the silence after the shots and realise that, somehow, we're here to hear it. The world could have been many things, chaotic, sterile, empty. But it chose to be this, a place where atoms hold together, where light finds its way through the dark, and where consciousness blooms long enough to marvel at it all. It makes you wonder if luck is the right word after all. Perhaps what we call luck is simply the shape of inevitability seen from within. Or perhaps it's grace, the quiet alignment of things that allows the impossible to keep unfolding. Whatever it is, it's the reason you can read these words, breathe this air and feel your heart beating, the echo of perfect balance written into every cell, every star, every moment of being. And as our path unfolds, we'll step closer to that cosmic control panel, exploring how delicately those dials are tuned. We'll see just how narrow the window of existence truly is, how easily the universe could have been silent, and how exquisitely it chose to sing instead. If we follow the thread a little further, we arrive at a room that doesn't really exist, at least not anywhere you can find on a map. And yet, every atom in the universe seems to remember it. You could imagine it as a vast, dimly glowing chamber, the cosmic control room. Along the walls are countless dials and sliders, each one setting the values of the universe's laws. None of them bear numbers or labels, only faint symbols of meaning. Gravity, light, charge, mass, time. Each dial is turned to just the right place, not by hand perhaps, but by whatever balance allowed the cosmos to unfold. It's a comforting illusion, this room of control. In truth, there is no operator, no panel, no physical space where these choices were made. But the image helps us imagine how precarious existence really is, how narrow the window of possibility had to be for a universe like ours to exist at all. Every constant, every law, every force must lie within a breathtakingly small range. A universe even slightly different would collapse, scatter, or freeze before the first star could breathe. Let's walk gently through this imagined room and look at a few of its settings. The first dial we come to is gravity, the oldest and most patient force. Its knob is turned to an almost impossible delicacy. If it were a little stronger, the universe would have folded back upon itself soon after the Big Bang, collapsing into a single heavy silence. If it were a little weaker, matter would never have gathered into stars or galaxies. The universe would have spread out like mist, too thin to ignite. Somewhere in between lies just enough pull to bring the atoms together without crushing them. That middle ground, that single sweet spot, is where you're sitting now. Next, we drift toward the dial of electromagnetism, the force that gives atoms their spark and light its colour. Its setting determines how tightly electrons are drawn to protons and how easily atoms can form bonds. If this force were a fraction stronger, atoms would cling too fiercely. Chemistry as we know it would break down. Electrons would collapse inward, and the world would become a featureless solid. If weaker, the opposite. Atoms would barely hold together, molecules would unravel, and nothing would stay stable for long. Life depends on that perfect middle tone, where matter is neither too stubborn nor too fragile. On another wall lies the control for the strong nuclear force, the clasp that binds the nucleus of every atom. Its adjustment must be even more precise. If the strong force were just a few percent weaker, protons and neutrons wouldn't bind into deuterons, the first building blocks of helium. The cosmos would be left with nothing but hydrogen, and the stars would never forge heavier elements. No carbon, no oxygen, no iron, no breath, no thought. But if that same force were only a touch stronger, the story would collapse in the opposite direction. Every proton and neutron would stick together too eagerly, forming heavy elements immediately. The early universe would become a single lump of dense matter, with no light at all. Everything we call chemistry, the language of life, would be erased. Even the tiny difference between the masses of protons and neutrons is tuned with eerie precision. Neutrons are just a little heavier than protons, not by much, just enough to make the world possible. If they were lighter, all hydrogen would have vanished, fusing into helium in the first seconds of creation. The stars would burn out quickly, leaving no second act. If they were heavier by even a sliver, neutrons would decay too rapidly, and atoms could never find stability. The universe lives on the knife's edge between two impossibilities, and then there's the balance between matter and antimatter, the most delicate symmetry of all. In the beginning, for every particle of matter, there was one of antimatter identical in every way except for charge. When they met, they annihilated each other in perfect flashes of light. Yet, by some deep and unexplained quirk, matter slightly outnumbered its twin. For every billion pairs that destroyed one another, one particle of matter remained. That faint imbalance, one part in a billion, became everything, every galaxy, every planet. Every living creature is made from that tiny excess. You could say the entire universe is built upon a cosmic rounding error. When scientists look at these values, the constants that define our world, they can't help but wonder how all the pieces fit so seamlessly. Why these numbers and not others? Why this exact strength of gravity? this particular charge of the electron, this particular speed of light. None of the laws we know can predict them. They simply are what they are. They appear as though the universe chose its own settings before turning itself on. It's important to remember that this fine-tuning doesn't mean the universe is fragile. It's resilient, vast, and endlessly creative. But the conditions for this kind of universe, one with structure, light, and life, depend on a web of balances that are almost impossibly precise. When you trace those balances down to the scale of atoms, you find a harmony so subtle that it feels less like mechanics and more like music. Every constant is a note, every force a rhythm, every interaction a chord in the grand composition of existence. You could say that creation, at its core, is an act of tuning, a cosmic orchestra finding harmony out of chaos. For billions of years, those notes have never gone out of tune. The same frequencies that guided the birth of the first atom still resonate in every heartbeat, every flicker of fire, every sunrise spilling light across the earth. Perhaps the strangest part of all is how the universe seems to know how to stay balanced. Stars burn their fuel in steady cycles, not too fast, not too slow. Planets orbit in delicate rhythms, neither freezing nor falling into their suns. Even chaos follows patterns that, when viewed from afar, feel almost peaceful. It's as if the universe has learned how to hold its breath, how to exist on the edge between destruction and creation, moment by moment, without ever tipping fully into either one. And so, when we speak of fine-tuning, we're not only speaking about physics, we're speaking about poetry, the poetry of numbers and the quiet intelligence of balance. The universe may not think, but it behaves as though it understands how fragile beauty is. It holds every atom in place just firmly enough to endure, yet loosely enough to change. It's this perfect compromise between too much and too little, too soon and too late, that makes everything possible. If you could stand again in that imagined control room, surrounded by its endless glowing dials, you might feel something close to gratitude, not to any one hand that set the knobs, but to the fact that they exist at all, that the dials found a way to align themselves in just the right harmony to produce light, chemistry, and consciousness. That they created a world that can ask questions and wonder why the answers are so beautiful. And as the lights of that room fade, our path carries us toward the mystery behind the tuning itself, the question of how this fragile balance came to be. Was it luck, design, or something far vaster? An infinite sea of universes, each with its own laws, its own symphony, and its own brief moment of light. Our journey now drifts toward one of the oldest and softest questions in all of science, one that floats between physics and philosophy, between numbers and wonder. How is it that everything fits so perfectly? Why do the laws of the universe seem written not for chaos, but for harmony? For centuries, humanity has looked at the stars and asked why they shine, why the world is stable, why matter holds together instead of falling apart. But now, with all we've learned, the atoms, the forces, the balances, the question becomes deeper. Why can the universe exist at all? There are three great ways we've tried to answer this question. None can be proven beyond doubt. They are not competing truths, but different kinds of poetry. Three stories the universe might be telling about itself. The first answer is the simplest, and perhaps the hardest to accept: luck. Pure coincidence. The cosmic dials, by some unimaginable chance, just happened to land on the right settings. The laws could have been otherwise, and in countless other possibilities nothing would have formed, no atoms would have held, no eyes would have opened. But somehow in this one, everything worked. It's a story of staggering odds and quiet gratitude. You might think of it as a cosmic lottery. Each constant, each law, each value was a draw, and every draw came up exactly right. It seems impossible. But then, impossibility is only measured by what survives to notice it. In all the universes that didn't form, there is no one left to say how unlikely they were. Only here, in the one that did, can we look around and marvel at the outcome. We find ourselves standing in the narrowest corridor of possibility, surrounded by endless doors that never opened. If that idea feels too thin, too lonely, there is the second answer: design. Not in the narrow sense of a blueprint or a builder, but in the broader sense that perhaps the universe has purpose. Maybe the laws are as they are because they were meant to be, tuned not by accident but by intention. You don't have to imagine a hand turning dials or a mind sketching plans. The design might be deeper, woven into the logic of existence itself. In this story, the universe behaves like an artist more than an engineer. It seeks harmony. It discovers beauty. It arranges its forces not for survival, but for elegance. Even the equations of physics, those long strings of symbols and relationships that describe the dance of particles and light, often seem to prefer simplicity and symmetry, as if the cosmos were choosing the most graceful way to express itself. Perhaps, in some quiet sense, beauty and truth are not separate things. Perhaps the universe is the kind of place where beauty is truth. Of course, to some minds this feels comforting, to others suspicious. We project purpose easily. We see design in clouds, in constellations, in coincidence. But even if the universe is not designed for us, it remains true that we are designed by it. Our eyes evolved to catch light because light already existed. Our minds evolved to find pattern because the cosmos is made of patterns. In a way, we are the proof that the universe produces meaning, because we are its way of thinking about itself. Then there is the third story, perhaps the most humbling, the multiverse. In this view, there isn't just one universe, but countless others, each with different rules, different balances, different fates. Most of them are barren, empty, unable to form atoms or light. But in a few rare places, perhaps only one among trillions, the settings fall into place just right, and stars can shine. We live in one of those places not because it's special, but because it's the only kind of universe that allows observers to exist. It's like bubbles rising in an infinite ocean. Most pop before they ever reach the surface, collapsing in silence. But a few hold long enough to shimmer, to reflect light, to catch colour. Those are the universes where existence becomes visible. The multiverse idea doesn't make our universe less miraculous. It only changes the kind of miracle it is. Instead of being a one-time accident, it's part of an endless cosmic experiment. Countless tries, countless beginnings, each exploring a different version of possibility. And if there are indeed countless universes, each with its own laws, then we might imagine reality as an enormous tree. Every branch a different world, every leaf a different outcome. Our branch happens to bear fruit because the sunlight here is just right. We can't see the other branches, but we can sense the tree's vastness in the balance that surrounds us. None of these answers, luck, design, or multiverse, can be proven beyond dreaming. But all three offer ways to hold the wonder. Perhaps the truth is a mixture of them all. Maybe the multiverse is real, and within it, beauty still guides what survives. Maybe luck is the shadow of some deeper necessity. Maybe the universe simply had to be this way for awareness to bloom. What matters is not which story you choose, but that the question itself is asked. The act of wondering is part of the same pattern as the stars, the same creative impulse that allowed atoms to assemble, galaxies to spin, and consciousness to awaken. When you ask why the universe exists, you're not outside of it looking in. You are the universe, asking itself how it came to be. So here we are, standing beneath a sky that glows with light older than time, surrounded by matter that once danced in the first fire of creation. Every atom in your body remembers that story. Every breath you take is balanced between the same laws that balance the galaxies. Whether by chance, by design, or by countless trials across infinite space, the result is the same. A universe that can hold you, a being capable of awe. And maybe that, in the end, is all the answer we need. The universe doesn't owe us an explanation. It is the explanation. A symphony that plays itself, a light that remembers itself, a question that became aware enough to ask. As our journey moves onward, we'll step back from the dials and theories and look at what this balance has made possible, how the atoms that survived these cosmic odds came together to create stars, worlds, and the quiet, flickering miracle of life. Because if the universe is tuned, then life is its melody, the soft song rising from the harmony of its laws. The path now carries us from the delicate balance of the early universe into its grand next chapter, the age of stars. The cosmos, once filled only with hydrogen, helium, and the faint glow of its own childhood light, was about to learn something entirely new: how to build. Out of that simplicity, the universe would discover complexity. It would learn how to create warmth, colour, and, eventually, life. You could think of stars as the great furnaces of patience, immense, silent hearts scattered through the dark, quietly working on a task that takes billions of years to complete. They are the universe's slow alchemists, turning the simplest elements into the ingredients of everything that follows. It all began when gravity, that patient sculptor, pulled clouds of hydrogen together. Over time, long, unhurried stretches of time, those clouds grew denser, their centres heating as the weight above pressed inward. When the temperature reached a few million degrees, something miraculous happened. The weak and strong forces, those quiet powers within atoms, joined hands to ignite the first fusion. Hydrogen began merging into helium, releasing vast energy in the process. A star was born. That first light wasn't gentle, it was fierce, radiant, and pure. Energy released as if the universe were breathing out after holding its breath for eons. But from that energy came order, and from that order, creation. Inside these early stars, fusion acted like a heartbeat. Steady, rhythmic, patient. Over ages, those heartbeats continued, turning hydrogen into helium, then heavier and heavier elements. Carbon, oxygen, nitrogen, silicon, iron, all were forged in the quiet interiors of stars that lived and died before our sun was even born. Every atom of carbon in your body, every cell, every breath, every thought, was once part of that cosmic chain reaction. The calcium in your bones, the iron in your blood, the oxygen in your lungs, each one was made by a star's long and gentle labour. The universe was not content with emptiness. It kept refining itself, learning how to weave complexity out of simplicity. You could say that every heartbeat of yours was once a pulse, inside a star. Every flicker of warmth you feel on your skin is a continuation of the same process that began billions of years ago. The stars are still working, still fusing, still sending their light across the vast night like distant lullabies of creation. Eventually the stars ran out of fuel. The smallest ones faded quietly into white embers, cooling slowly over time. But the larger ones, the giants, had a different fate. Their cores grew so heavy that gravity and pressure waged a final catastrophic battle. When the balance tipped, the star collapsed inward and then exploded outward in a single luminous instant. A supernova, the death of a star and the birth of countless worlds. In that moment, everything the star had made in its long life, all the carbon, oxygen, iron and gold, was scattered across space. Those atoms became seeds drifting through the cosmic garden, waiting to gather again into new clouds, new stars, new planets. The cycle began anew, creation through destruction, order born from collapse. The universe, it seemed, had learned to recycle itself. If you could see it unfold, you would witness something both violent and graceful, a bright blossom of light blooming and fading in the dark. For a few weeks, a single supernova can outshine an entire galaxy, but its brilliance is not the end. It's a beginning disguised as an ending. The debris expands, cools, and mixes with the interstellar gas. Slowly, almost imperceptibly, gravity begins its patient work again, pulling the scattered material together. From the ashes of old stars, new generations are born, stars like our Sun and planets like our Earth. This process, called stellar recycling, is how the cosmos keeps its promise to evolve. Nothing is ever truly lost. Every atom that was once part of a distant star will someday find a new home, in a planet, a plant, or perhaps a person. You're made of ancient remnants, of stardust reshaped by time. When you breathe, you are participating in the same chemistry that began in the heart of the first stars. When you look up at the night sky, you are looking at your ancestors. Even now, as the universe grows older and more spacious, stars continue this work of renewal. In nebulae, those glowing, colourful clouds scattered across the galaxy, new stars are forming from the remains of the old. The cycle continues, light giving way to matter, matter to life, life to awareness, and awareness back to wonder. Our own sun, gentle and golden, is part of this lineage. It is not a first-generation star, but a child of many before it. It inherited its atoms from the supernovae that once filled this corner of the galaxy. That's why your blood carries iron, the same element that once burned in the heart of a dying star. The sunlight falling on your face today is a continuation of that same story. Energy released from fusion reactions deep within the sun's core, crossing 93 million miles to find you here. If you hold out your hand in that light, you can almost feel the story move through you. The warmth of atoms that once drifted through space, gathered, burned, and began again. It's a reminder that the universe never wastes its light. It transforms it. It reuses it. It teaches it to live. When you think of it this way, the stars are not distant at all. They are inside you. Their dust became your bones. Their light became your warmth. Their rhythm became your heart. In a quiet, literal sense, you are the universe continuing its experiment in self-expression. The same atoms that once built stars now forming thoughts about stars. It's a breathtaking circle. The cosmos learned to make light, light learned to make matter, matter learned to make life, and life learned to look back and wonder. And if we follow that circle just a little further, we arrive at something even more intimate, the chemistry that keeps that starlight alive within you every day. Because what began in the hearts of stars didn't end with their explosions. It continued in the small miracles of molecules, in the gentle bonds that let atoms hold hands and share energy. The next part of our journey will bring that vast cosmic history down to something as simple as breathing, the quiet conversation of atoms that keeps you alive, moment by moment. If we follow the thread a little further, the story becomes smaller, but also more personal. The stars have done their work. The great furnaces of the universe have cooled, scattered their ashes, and left behind the ingredients of everything we know. Now those wandering atoms begin to meet again, to join hands, to form bonds, to build a soft architecture of life. This is where the grand story of the cosmos becomes the story of you. Take a quiet breath. The air that fills your lungs is ancient. The oxygen you inhale was born in the heart of a long-dead star, carried across light years, mixed into Earth's oceans and sky, and finally, after 4.5 billion years of patient recycling, found its way into you. The iron in your blood, the calcium in your bones, the carbon in your skin, all of it forged from the remains of stars that lived and died before the sun was even born. When you breathe, you're rejoining that cosmic conversation. It's a strange thought, but a comforting one. The air that moves through your chest once drifted through the lungs of birds, trees, even ancient oceans. The atoms do not disappear. They travel endlessly, changing partners, but never the dance itself. They belong to no one and to everyone. When you exhale, you return them to the world, ready to become part of someone or something else. In this way, breathing is not only biology, it's participation. At the heart of this participation lies chemistry, the quiet art of connection. Atoms, by their nature, are social creatures. They rarely exist alone for long. Each has a nucleus, heavy and positive, surrounded by a halo of electrons that hum softly in invisible motion. Those electrons are what make atoms reach out to one another. When two atoms draw close, their electron clouds overlap, not colliding, but merging gently, like two candle flames meeting. In that overlap, they share. That act of sharing is what we call a bond. If you could shrink down far enough to see it, you might picture atoms as dancers in an endless waltz. Each holds a certain rhythm, some leading, some following, and when their steps align, they stay together. Hydrogen, the simplest of them all, loves to share with almost anything. Oxygen prefers pairs, seeking stability by holding two partners in its embrace. Carbon, ever generous, can bond with 4 others at once, building vast networks, the skeletons of every molecule in your body. When atoms bond, they create molecules, and when molecules gather, they create structure. The same pattern repeats at every scale. Tiny arrangements become chains. Chains twist into spirals. Spirals fold into forms capable of storing energy and memory. The difference between a drop of water and a leaf, between a gust of wind and a heartbeat, lies not in the atoms themselves, but in the way they link. Nature doesn't need new ingredients to make something extraordinary, only new relationships. Think of something as simple as a cup of tea. The warmth you feel rising from it is the motion of atoms, vibrating faster as they share heat. The aroma, those familiar scents, are molecules finding their way to your nose, gently binding with receptors in a pattern that your brain translates into memory. Even the colour of the tea, the golden hue that catches the light, is the result of electrons absorbing and releasing energy. Every sensation, every experience is a dialogue between atoms, a symphony of tiny exchanges happening far too quickly for us to notice. The same chemistry shapes the body that experiences it. The oxygen you breathe travels from your lungs into your blood, where it meets the iron atoms at the centre of hemoglobin molecules. Those iron atoms hold onto the oxygen gently, not too tightly, not too loosely, releasing it when it's needed, passing it from cell to cell. It's a partnership of trust, a molecular handshake repeated trillions of times every second. Every breath you take is a quiet act of coordination between elements born billions of years apart, now working together to keep you alive. In the same way, carbon forms the backbone of life's molecules, long chains that fold into loops, twists, and spirals. The sugars in your blood, the proteins in your muscles, the DNA in your cells, all are built from carbon's willingness to connect. It's as if the universe took its simplest building blocks and taught them to cooperate, to form patterns that could store and share energy. And in doing so, it discovered meaning. When you look at your reflection in a window, you are seeing chemistry at work. The light bouncing off your skin is absorbed and re-emitted by the atoms of melanin, water, and collagen. The colour of your eyes comes from tiny arrangements of molecules that scatter light just so. Even emotion, that surge of warmth when you laugh, the tightening in your chest when you feel love or fear, is chemistry too. Tiny molecules move between cells, carrying signals that become thoughts, thoughts that become feelings. It can feel humbling to realise that the very things that make you human, love, longing, creativity, are built on the same interactions that hold a molecule of water together. But it can also feel miraculous, because somehow, through these invisible bonds, atoms learn to care. They learn to link, to share, to create systems that could feel the difference between existence and nothingness. The same forces that shaped galaxies now shape tenderness. The chemistry of life is, in a sense, the universe's way of learning empathy. Everything around you, the warmth of sunlight on your skin, the sound of your own breath, the flavour of your favourite meal, is a gentle conversation between atoms. Each moment you are surrounded by countless invisible handshakes, each one a reaffirmation of connection. Matter doesn't only exist, it participates. And so, in every breath you take, you are both an individual and a continuation of the cosmos. The oxygen in your lungs was once trapped in ice, then released by a volcano, then carried by a storm. The carbon in your body was once buried in the shell of a star. The hydrogen in your blood has been around since the beginning, unchanged, unaging, eternal. You're made from these same patterns, animated by the same chemistry that built the world. If you close your eyes and breathe slowly, you might even feel it. The subtle pulse of the universe moving through you, as if the stars were still whispering through your veins. Every breath is a reunion, every exhale a return. And if we follow this story one step further, we'll find that chemistry leads not just to life, but to awareness, that somehow from these quiet exchanges between atoms, consciousness itself emerged. The universe didn't just build living things, it built something that could look back, wonder, and remember. If we follow the thread a little further, it leads us into perhaps the most astonishing transformation in the entire story. The moment when matter began to think. It didn't happen suddenly, like a switch being flipped. It was more like the slow dawning of awareness in the universe itself. Over billions of years, the atoms that had learned to link and share began forming patterns so complex that one day they looked back and asked, "Why am I here?" It's almost unthinkable. The same hydrogen that once floated in the quiet of the early cosmos now flows through your veins. The same carbon that glowed in the heart of ancient stars now shapes your brain. Somehow, from the chemistry of stars and oceans, from dust and light, the universe found a way to create something that could imagine its own origins. To understand how that happened, imagine the simplest beginning. Long ago, Earth was a young planet covered in oceans and storms, with sunlight spilling across its surface. Inside those waters, atoms and molecules, carbon, hydrogen, oxygen, nitrogen, were drifting, colliding, breaking apart and reforming in endless combinations. Each interaction was a quiet experiment, testing new possibilities. Most combinations led nowhere, but a few learned persistence. They formed loops, chains that could make copies of themselves, storing tiny instructions within their structure. Those loops were the first whispers of life. They were simple, fragile, and unaware, but they carried a crucial gift: memory. For the first time, matter could remember its shape, could replicate it, could improve upon it. You might say that matter had learned how to learn. From that single step, evolution began, not by design, but by patience. Over time, these molecular loops grew more complex. They learned to build walls, membranes that separated inside from outside. They learned to harvest energy from sunlight and minerals, turning it into motion, growth, and repair. The strong and weak forces still worked beneath everything, binding nuclei and driving reactions, while electromagnetism stitched molecules together. But now those same forces had learned a new language, the language of biology. From chemistry came cells. From cells came tissues. From tissues, creatures that could swim, crawl, walk, and dream. At every level, atoms built systems that could sense, react, and adapt. And then, in time, one small lineage of living matter, ours, developed a nervous system intricate enough to reflect, to feel, to imagine. Somewhere in that long chain of trial and error, consciousness appeared. The universe, through atoms, had found a way to become aware of itself. Pause for a moment and let that thought settle. Every idea you've ever had, every memory, every flash of inspiration or love, is the result of atoms in your brain communicating through electrical signals. The same electrons that once orbited a nucleus billions of years ago now carry thoughts across networks of neurons. Your mind is a constellation of moving charges, the same energy that powers stars, rearranged into the quiet spark of awareness. You're not apart from the universe's story, you are the continuation of it. The hydrogen in your blood was born in the Big Bang. The oxygen you breathe was born in stars. The calcium in your bones was born in a supernova's final light. Those same atoms, once scattered and lifeless, have gathered here, in you, to look out through your eyes and wonder where they came from. The universe built you out of its own memories. Matter became memory, and energy became thought. Sometimes, people imagine that consciousness is separate from the physical world, that mind and matter belong to different realms. But perhaps the opposite is true. Perhaps the mind is what matter does when it reaches a certain complexity. The universe's way of folding back upon itself like a wave curling on an ocean. The ocean doesn't stop being water when it forms a wave. It simply takes a new shape. In the same way, the cosmos doesn't stop being atoms when it forms you. It has simply learned to think. If you close your eyes and let your thoughts drift, you might feel that connection. The faint hum of the same physical laws that shape galaxies, now echoing in your own awareness. Every neuron firing in your brain follows the same rules that guide the dance of electrons in distant stars. The light that moves through your mind when you imagine something is kin to the light that travels between galaxies. You're made of the same equations, only slowed, softened, and given voice. And with that voice, the universe can now ask questions it could never ask before. Through you, it wonders what it is, what it means, and whether it has purpose. Through art, music, love, and science, it contemplates itself. You are the universe's curiosity given form. When you gaze at the night sky and feel awe, that feeling is not separate from the stars. It is the stars remembering what they are. Consciousness, in this view, is not an accident. It's the inevitable result of a cosmos built to connect. Atoms are linked to form molecules, molecules linked to form life, and life linked to form awareness. Each step required more cooperation, more complexity, more sharing. The same impulse that made electrons hold hands now makes minds hold ideas. There's a kind of grace in that. Every act of empathy, every moment of understanding between two people is an echo of the same chemistry that keeps the universe together. When you comfort someone, when you laugh with them, when you fall in love, your atoms are participating in the universe's oldest instinct, the desire to connect. And so, as we arrive here, at the quiet realization that matter can think, the story feels less like science and more like poetry. The universe began with silence, learned how to make light, then learned how to sing, and finally, how to listen. You are that listening. You are the cosmos tuning in to its own song. If you ever doubt your place in the grandness of it all, remember this. You are not small, not really. You're vast, built from billions of years of memory, carrying within you the same spark that lit the first stars. You're made of atoms that have seen everything, from the birth of light to the quiet miracle of thought. And in that awareness, the universe completes a circle. What began as energy has become reflection. The story that started in a flash of brightness now lives in your consciousness, in your ability to wonder, to imagine, to care. As we drift onward, we'll follow that light one last time, the same ancient glow that still hums across space, carrying with it the memory of everything that ever was. Because even as the stars fade and time stretches thin, that light, the universe's first word, still travels, still sings, and still remembers. If we follow the thread a little further, it brings us back to where everything began, to the light that has never stopped moving. Long before there were stars or planets, or even atoms, that light filled the universe like a warm breath. It's still here, still stretching, still singing across time. The universe has changed in every way since then, but that first light, the one that escaped when atoms first formed, continues to travel, carrying with it the memory of everything that ever was. You can't see it with your eyes, but it fills every corner of the sky. The cosmic microwave background, that ancient afterglow we once called the baby picture of the universe, is still humming gently, a lullaby from the dawn of time. It has cooled over the ages, its colour slipping from bright fire to invisible warmth, its wavelength stretched as space expanded, but it hasn't stopped. It never will. Not until the universe itself grows too wide, too thin, too quiet for light to travel at all. Every second, those ancient photons, tiny packets of energy born from the universe's first breath, pass through you. They move through your walls, your skin, your body without notice or sound. They're too soft for your senses to feel, but they're there, a constant gentle drizzle of memory. You are bathed in the light of creation, every moment of your life. If you could somehow listen to that light, you'd hear a faint hiss, the same sound that once puzzled Penzias and Wilson in their great antenna. It's the whisper of the cosmos, stretched thin but never gone. Scientists have measured it, mapped it, and painted it into colour, transforming invisible waves into pictures that tell the universe's story. Each small variation in that light, a tiny patch slightly warmer or cooler than the rest, marks the places where matter first began to gather, where gravity started pulling atoms together, where the first galaxies would one day bloom. The entire cosmic web, billions of galaxies strung across the void like dew on an invisible net, was written in those early ripples of light, and that same light is still unfolding, still showing us the blueprint of how everything came to be. It's strange to realise that when you look into the night sky, you're not just seeing the present, you're seeing echoes of the past, light that began its journey long before Earth even existed. Every star you see is a time traveller, every glimmer a message from a different age. Light has a peculiar gift. It moves faster than anything else can, yet it also records slowness. It keeps history visible. When you look at the moon, you see it as it was 1 second ago, the sun as it was 8 minutes ago, the nearest stars years ago, the farthest galaxies, billions of years ago when the universe itself was young. In that sense, light is not only energy, it is memory made visible. It carries the universe's autobiography, written across space. You might think of it as a river that never stops flowing. It begins at the source, the fusion within stars, the first fire of the cosmos, and travels outward forever. Some of it finds its way to planets like ours, warming oceans, nurturing life, illuminating thought. Some will drift through empty space until the end of time, faint and slow, yet still true to its origin. The light that began your atoms has already crossed unimaginable distances, and in some quiet future, it will continue its journey through others. There's a poetic symmetry in that. The same light that first filled the universe is now passing through your body as you read these words. It has touched everything. The atoms of distant stars, the cold dust of forgotten nebulae, the water in your veins. Light doesn't belong to one place. It belongs to everywhere. Every beam, every photon, every shimmer of brightness carries the same message. I have travelled through everything, and everything is connected. Over the next trillions of years, as the universe expands and cools, that ancient light will grow fainter still. Its wavelength will stretch beyond microwaves, beyond radio waves, until it is too weak to detect, a final, fading hum in an ocean of silence. Astronomers call this the heat death of the universe, but the phrase feels too final, too cold. Perhaps it's better to think of it as the last note of a song slowly drifting away, never fully gone, only quieter. When that time comes, the stars will have long since burned out, their ashes scattered among the galaxies they once lit. The atoms that made us will be adrift again, waiting for whatever comes next, and the light that once touched us will still be travelling, its energy diluted but not lost, like the echo of a heartbeat still bouncing down an endless corridor. But we are not there yet. We live in a universe still filled with light from stars, from galaxies, from that first great flash of freedom when the cosmos became transparent. And that light, after all this time, still knows how to find us. It slips through telescopes and windows, through air and atmosphere, through the tinier spaces between atoms. It paints our world with colour, nourishes the life that grows upon it, and reminds us of our place in something vast. Every evening when you watch the sky darken and the first stars appear, you're watching the continuation of a story that began before time had meaning. Those stars are the keepers of memory, their light stretched across billions of years to reach your eyes. The same glow that once filled the young universe now settles softly on your skin. The cosmos has been speaking all along, in wavelengths too long for ears to hear, too subtle for eyes to see. And yet, somehow, we feel it. The light that began your atoms will one day end its journey, but not before passing through you, through everyone you've ever known, through every life that will ever exist. You are part of its path, a chapter in its journey, a flicker in its reflection. And when it moves on, it carries the memory of everything it has touched. So tonight, as you sit quietly, perhaps looking up at the dark sky, remember that you are illuminated not from without, but from within. You are made of light slowed down, light that learned how to take form, light that remembers where it came from. Every thought you have, every kindness you show, every spark of curiosity is that same energy finding a new way to shine. And as we move gently toward the end of this story, we'll bring that idea home. That everything we've followed from the first flash of creation to this quiet moment of reflection is part of one great memory. Because the universe has never forgotten itself. It is still glowing, still travelling, still remembering, through you. And so, our story comes full circle, from the first flicker of light to the quiet glow within you now. What began as energy bursting into being has become thought, feeling, memory, and breath. The atoms that once drifted through the silence of space now speak through your heartbeat. The light that once roamed the newborn cosmos now warms your skin. Every part of you, every cell, every breath, every passing thought is an echo of the universe learning to know itself. When we talk about the cosmos, it can sound impossibly vast, like something far away, unreachable. But distance is an illusion. The stars above you are not strangers. They are family. Their light is in your eyes, their dust in your veins. The space between galaxies may be wide, but it's filled with the same quiet energy that moves through your own body. The boundary between you and the universe is only a story the atoms tell. And even that story is made of starlight. Think back to where it all began. There was nothing. No form, no sound, only a sea of light waiting to become matter. From that light came atoms. From atoms came stars. From stars came worlds, oceans, mountains, and eventually life. And from life came awareness. You. Every heartbeat, every breath, every gentle thought is a continuation of that first act of creation. In a sense, the universe has never stopped creating. It didn't end after the Big Bang or after the first stars were born. It continues every time a seed breaks open, every time a child laughs, every time you look up and feel awe. The act of noticing, of wondering, is creation still unfolding. The cosmos expands not only outward into space, but inward into understanding. You are part of that expansion. Every memory you form is a pattern of atoms, shifting, storing, connecting. Every idea you have is a small rearrangement of starlight, given a new rhythm. When you speak, you turn breath, air made of oxygen and carbon, made of stars, into meaning. When you listen, those same atoms carry vibrations through the air, turning them back into thought. The entire world, when seen this way, becomes a conversation between matter and mind. And it's not just poetry, it's physics made gentle. Energy doesn't disappear, it transforms. The warmth of your skin tonight is the remnant of light born billions of years ago. The electricity moving through your brain follows the same rules that guide lightning, or the magnetic fields that spiral through galaxies. The boundaries we draw between cosmic and human, between science and soul, are thinner than we think. The laws that hold galaxies together are the same laws that hold you together, atom by atom, thought by thought. It's strange to realize that the universe's memory, everything it has ever been, is stored not only in the stars but in you. When you remember your childhood, or a loved one's smile, or a song that once made you cry, that act of remembering is the cosmos reflecting upon itself. Matter remembering matter, energy recognizing energy. The universe, after billions of years of silence, now has a way to whisper back, I remember. When you look at the night sky, you might feel small, a single life among billions of stars. But perhaps it's the other way around. Perhaps the stars feel small compared to you, because through you, they can finally see themselves. They burn and shine, but they cannot know their own light. You are that knowing. You are the awareness that completes their story. Even your breath carries this connection. The oxygen you inhale was made in stars that died long before our sun existed. The carbon you exhale will one day feed plants that turn it back into life. You breathe in the universe, you breathe it back out. The cosmos doesn't end where your skin does. It moves through you, in and out, endlessly. And so, as the stars fade over the horizon and the night deepens, you might feel the quiet hum of that connection. Every part of you belongs to a rhythm older than time, the rhythm of creation, destruction, and renewal. The same rhythm that pulses through galaxies hums softly in your chest. The universe is not somewhere out there. It's here, within you, around you, as you. In the end, that may be the truest meaning of the story we followed. Not that you are in the universe, but that you are the universe, awake for a little while. The cosmos is vast, but it isn't indifferent. It gave you the ability to love, to laugh, to question, to remember, and in doing so, it found a way to feel. Everything you've ever touched, everything you've ever loved, everything you've ever been afraid to lose, all of it will change form one day, but none of it will disappear. The atoms will go on, reshaping themselves into new stars, new worlds, new lives. Even when you're gone, the light that moved through you will still travel, still shimmer somewhere in the dark, carrying the story forward. So, as you rest tonight, know this. The warmth in your chest is the memory of the first light. The breath you take is the echo of the universe learning how to build. The thoughts drifting through your mind are starlight slowed down, folded gently into awareness. You're not apart from the cosmos. You're its dream, its question, its moment of reflection. Sleep, little constellation of atoms. The cosmos is within you, always remembering itself. The same light that began before time is still moving through you now, softly, endlessly, waiting for you to close your eyes and join its rhythm again. And as your breathing slows and thought fades to quiet, the universe keeps going, patient, infinite, kind. Somewhere out there, light is still travelling, still humming its ancient song. And here, within you, that same song continues, the quiet pulse of existence, steady and eternal. Rest now, traveller made of stars. The story will keep shining